In this video, we're going to be going over graphing polynomial functions. The first thing that you need to know about graphing polynomial functions is understanding the end behaviors of the graph. So at the end of the graph, you want to make sure to know whether the graph is going to go up or down. And the end behavior of a polynomial function is a behavior as x approaches infinity from the positive and negative side. The degree and the leading coefficient of the polynomial is going to help you determine how the graph is going to go. If the exponent of the leading term is even, then it's going to go to the same direction. It can either go both up, so both ends are going to go up, or both ends are going to go down. And that only happens when it's an even exponent. But whenever you have an odd exponent, then they're going to go to the opposite direction. So they may start from the negative side and they're going to end up in the positive side, or they may start from positive infinity and they're going to end up in negative infinity. If we have an even degree, and now we're going to be paying attention to the coefficient. If the coefficient is positive, then it's going to open up. So we may end up with a graph that looks like a parabola going up, or you may end up with something a little closer to that. But what matters is the endpoints are both going to be pointing up. If the coefficient is negative, and again, the degree is even, then we're going to have the opposite. It's going to be going down. So both endpoints are going to be going into negative infinity. For polynomials with odd degree and a positive coefficient, it's going to start from negative infinity, so it's going to be pointing down on the left hand side, and then it's going to go into positive infinity. Or you may have something closer to that. If the leading coefficient is negative, then it's going to start from positive infinity, so the first arrow on the left hand side is going to be pointing up, and then it's going to be going down. And again, this happens because they go to the opposite sides. Using the previous information, we want to determine the behavior of the function. So the only thing that we're going to be paying attention to is going to be the degree and the coefficient. So the degree in this case is 3. So we have degree is 3. And the coefficient in this problem, we have an invisible 1. So the coefficient is going to be positive 1. So based on the information that we had in the previous part, we know that because it's odd, it's going to be going into opposite directions. So odd means opposite. And because it's a positive 1, that means that we're going to go from negative infinity to infinity. So we know that the behavior of the graph is going to be something like that. We're only going to pay attention to the endpoints. For this problem, we have a exponent, or your degree is going to be 6. So the degree is 6, and your coefficient is negative 4. So for this problem, we know that because it's even, 6 is an even number, they need to either go both to the positive side or both ends go to the negative side. But because it's negative, we know for sure that they both have to be going to the negative side. So that's what we're paying attention to, both going down. We also need to consider the intercepts of the function. The y-intercept is found by making x equal to 0. That will be the point in which the graph will cross the y-axis. The x-intercept will be found by solving the equation f of x is equal to 0. For that portion, you may need to just do factoring. You may be able to complete the square or use a quadratic formula. In some cases, you're going to have to use the fundamental theorem of algebra, and you have to do P over Q to find the rational roots. For this example, we're going to be paying attention to the x and the y-intercept. The easiest one to find is going to be your y-intercept. So what we're going to do is just put 0 wherever we see an x. So that's going to be very quick. So we're going to rewrite this, but instead of x, we're going to put 0. That means that this is going to all cancel, and our y-intercept is going to be at a 175. So the point of interception is going to be at 0, 175. Now, the x-intercept are going to be more challenging. For that, we're going to have to go back and use the linear factorization theorem. So we're going to find the factors, and in this case we can do it by grouping. So in the first one, we're going to factor in x to the second power. So we have x minus 7, and then we're going to factor a negative 25 from the second group, and we have x minus 7, and we have x minus 7, x squared minus 25, and now we're just going to make this equal to 0. So we have x minus 7 is equal to 0, and we know that that's going to be x is equal to 7, and then we have x squared minus 25 is equal to 0. So we have x squared is equal to 25. When you find the square root, you get x is equal to plus or minus 5. So that means that your x-intercepts are going to be at 7, positive and negative 5, and then this is going to be your y-intercept. As it was mentioned, solving for the x-intercepts is going to be slightly different in every single time. So you may do factoring, or you can use synthetic division to find the intercepts of the polynomial. But something that you need to keep in mind is going to be the behavior at those intercepts. In the y-intercept, it's always going to cross, but in the x-intercept, it may actually cross if the multiplicity, so the number of times that answer solves the problem is odd, is just going to cross the graph. But if it's even, for example, if your answer is x is equal to 4 and 4, we say that the multiplicity in this case is 4 multiplicity 2. So in these cases, instead of crossing at the axis, it's going to actually bounce. So it's just going to touch and go back to the direction it came from. For example 4, once again you're going to have to find the x and y intercept of the function, and then now you're going to determine whether it's going to cross the x-axis or bounce. We are also going to add the end behavior. So once again, look, the end behavior, this is an odd and it's positive, so we know that as the end behaviors, we're just going to make a quick note, is going to look something like that, from negative infinity to positive infinity. The y-intercept, when you put 0 right here, this cancels, and this cancels. So the only thing that we're going to get is going to be 18. Again, the only thing I did is if we put a 0, 0, 0, everything there cancels. So our y-intercept is going to be just at x equals 0, y is going to be 18. The x-intercept in this case, I want to solve it slightly different. So for this problem, we're going to use synthetic division. So you need to be able to know all your possible factors using p over q. The first number that we're going to use is -2, so we put -2. We bring down the 1 and we have -2 times 1, -2, -4, and -2 gives me -6. When we multiply -2 and -6, we get 12. -3 plus 12 gives us 9. -2 times 9 gives us -18. So this number works. And now that we're at this point, you can keep going with synthetic division, or you can go into factoring. Just so you can see a different approach, I'm going to start going into factoring. So we have x squared minus 6x plus 9, and you are going to be looking for two numbers that when you multiply them gives you 9, but when you add them gives you -6. So that's going to be -3 and -3. So we have x minus 3, x minus 3, and that's equal to 0. So we know that we're going to get x minus 3 is equal to 0, x minus 3 is equal to 0. So we have x is equal to 3, x is equal to 3. So in this case, we have x is equal to 3 multiplicity 2. So using this information, we know that because we only have one answer right here, a -2, the graph at the x-axis at -2 is going to cross, but at x equals 3, that graph is going to bounce. So I'm going to make a quick sketch so you can get an idea of what we're talking about. From example 4, we know that your y-intercept is at 18. Your x-intercepts are going to be at -2 and 3 multiplicity 2, because we got that. And we also know the orientation of the graph. We know that it's going to start from below and it's going to go high. And now in this case, you can see that our y-axis doesn't have 18, but we're doing a quick sketch, so that means that we don't have to be 100% precise. So what we're going to do in this graph, and you may see it in the future, is whenever you have a graph that won't fit, they may do something like this. So that means that there's a chunk of numbers in between there, and we're just going to say that 18 is going to be somewhere here. That makes it so much easier to graph instead of having to create a super long graph. And then the x is going to stay the same. So we have -1, -2, -3, -4, and then +1, 2, 3, 4. So we know that we have two x-intercepts. We have one at -2, and we have one at 3. Based on our graph, we know that we need to start from the negative side and we need to end up in the positive side. So we are going to connect our points. And now, remember that at 3, we have a multiplicity 2. So at 3, this is going to bounce. So instead of crossing like it did a -2, it's just going to create a bounce, and then we go back up. And that's how we sketch. For example 6, I have already provided all the information. So we have, in this case, we have an even function because we have x to the fourth power, and we know that the coefficient in this case is going to be positive. So we know that this needs to be opening up. Now we're just going to put our points. So once again, the y-intercept is too large, so we're just going to scale it. So we have 135 there. Then we have 1 point at -3, 1 at -5, and then we also have 2 at 3. Since we know that this needs to start from the positive side because it has to go up, this has to go up from both ends, we're going to start from above because in this case we only have a multiplicity of 1. This is odd. It's going to cross, it's not going to bounce, and then it's going to cross again at -3. Now we're going to go to our y-intercept, and then at 3 it's going to bounce, it's going to go back up, and we're going to end with both ends of the graph going up. We're able to do this sketch without having to create a table and plug points.